Hello everybody, this is Dr. Khanal once again. Um, so we are here in chapter 5. We discussed um, most of the problems, like these static problems, where you have multiple number of forces, and the problem like this where all you have to do, the basic idea is get the x component of all the forces, where you have to have the angle with the positive x-axis, and also get the y component of the forces, and get the total of x component and total of y component, and what you do is after that you sum the total x component, that will be 0, and the total of y component will also be 0. And that's the basic idea of all those problems. So these are the static case. So let's go a little dynamic case, which is the Atwood's machine, which I gave a little bit of review in the class. Let me quickly solve this problem, which is problem number 5.15. There is a frictionless pulley, and you have a brick here. I call it mass 1 to make life easy, and there's another one, mass 2. The condition here is mass 2 is greater than mass 1. So what happens if one of the mass is greater, meaning the net force will be not 0 but something, it has some value, which means there must be an acceleration. So the question says draw two free body diagram, one for load and one for the counterweight, and what is the magnitude of the upward acceleration, and what is the tension of the rope. Anyway, the point here is find the acceleration and find the tension of the rope. So what I do is, let me see, I wanna zoom a little bit. This one, let me do it this way, and I'm gonna zoom it. Hope this is okay. So okay, let me do it on the landscape, and I wanna recall this 5.15, problem number 5.15. Okay, so let me redraw the diagram. There is a pulley, and you have a brick here, I call it M1, and M1 has the value of 15 kilogram, and then there's a counterweight. The counterweight is, I call it M2, second mass, which is 28 kilogram. All right, 28 kilogram. Excuse me. Now what happens here is, let me use another ink. I just wanna draw it right here with the red ink. So here the weight acts vertically downward. This M1 weight acts vertically downward, which I called mass 1 times gravity. That will be my force vertically downward. And actually the force will be a little bit shorter compared to, like, the tension here will pull upward. I call it tension. I don't need to call it tension 1. The reason is the tension on this and tension on this counterweight will be the same. This tension and this tension will be the same. So I can call it T1 equals to T and T2 equals to T, but since it is same, because you have frictionless pulley, and it doesn't slip, so what it means is it has the equal tension. The string is uniform. So uniform string has equal tension on every side. So on this side, what happens is, since this is only 15 kilogram, this one is 28 kilogram, this one is heavier, so of course it goes down, meaning this goes up. So in this particular case, your acceleration goes on this way, right? And then here the weight pulls it down. This one I call it mass 2 times gravity. All right, so now what happens here is, this mass 2 being greater than mass 1, the acceleration here goes downside on that one, but the magnitude of the acceleration remains same on both the sides. So if you look at on the left side, what happens here is, the tension is greater than the weight of mass 1. So on this side you have tension minus mass 1 gravity, right? Because tension is kind of winning to the load. So this one pulls up, but tension pulls, this one the weight goes down, but the tension want to pull up. Because of this mass being heavier than this, the tension on this side is greater than this one. So the net force is T minus weight. This will give you mass 1 times acceleration, mass times acceleration. So total, we know net force equals to, I'll write it here on top, total force equals to mass times acceleration, which is Newton's second law. So this is on your left side. So what happens on the right side is, this is greater, this one is greater than T. So on the right side, what happens is m2 times gravity minus T. So the net force here is this minus this, equals mass 2 times acceleration. Remember, the acceleration is same. Don't take like this one as positive, this one as negative. No, the reason here is, since this is like, let's say this is like a straight line. Okay, so let's make it straight. So what happens is, m1 gravity pulling this way, m2 gravity pulling this way. So tension here pulling this way and the tension here pulling this way. So in other words, this acceleration, magnitude of the acceleration is same. So you can take it either that way, or you can do it like separately, but never mind, I don't want to confuse you too much. So this one, you have two equations here. So if you have two equations there, what you can do is you simply solve it. So you have now two variables. This is known quantity, m1 is known, gravity known, m2 is known. So you have one variable t and the another variable acceleration. So the question is asking what is the acceleration. So what you do, you can just solve it. You can solve it means what? Since it's positive t, this is negative t, you can cancel it. You can just add equation 1 and 2. So okay, adding two equations. Okay, so what you get is, the t will cancel, so this guy will be m2 gravity minus m1 gravity equals, these are both plus, so this is let me write it here, m1 acceleration plus m2 acceleration. So what I want is, we want the question says find the acceleration and tension. So the acceleration will be mass 2 minus mass 1. You can factor out this gravity. So mass 2 minus mass 1 times gravity equals, you can take out acceleration also, mass 1 plus mass 2 times acceleration. So what this will give you is, acceleration equals m2 minus m1 times gravity divided by, this goes down, m1 plus m2. So now you plug the formula. By the way, what I have seen some of the students doing is, they just copy this formula straight away and then plug the numbers. You have your M2 is what? M2 you have 28 kilogram. Let me not write unit. I hope you guys are much familiar on unit anyway, because we have done so many times in previous chapters. So this one is kilogram, this one is meter per second square. So kilogram meter per second square will give you Newton. So I'm sorry, kilogram and meter per second square will give you Newton, but you have like kilogram down also, so kilogram and kilogram will cancel, so you are left with only meter per second square, and of course the unit of acceleration is meter per second square. So okay, so m1 is what? 15, and then your gravity is 9.8, which is meter per second square, of course, and divided by 28 plus 15. What I've seen the students doing is, if I ask you this question for about, let's say, 10 point or 5 point, actually 5 point is too low, but if I ask you 10 point or something, of course you cannot just copy this formula and plug those numbers. I mean, that's kindergarten way. There is no physics if you just copy, but you need to show why it comes. I mean, in the formula set, this formula will not be given because this is only for a particular case. So I'll do another problem here and I'll show you what will be the difference there. Okay, so here your answer will be, let me do it really quick. So the answer will be, let me use my calculator. Well, of course I have my phone here. In your test, unfortunately, you are not allowed to use phone, so so don't use phone. Okay, again I repeat, it's only for me. You use your own calculator. I don't have calculator right here with me, so I'm just using this for now. Excuse me. So it's 28 minus 15, and that gives me 13, right? And then times, what is it, times 9.8, times 9.8 equals to this much, whatever, and then divide by 28 plus 15. So, and then I do divide, and I have to put parenthesis. The reason here is it's in the denominator, which is 28 plus, where is plus 15. So this gives me 2.96, okay, 2.96 meter per second square. So now what you do? Now what you do is you need to get what? Tension. So what you do to get the tension? That's your B part. So the C is tension. You need to what? You need to replace the acceleration in any one of those equation. Okay, one of those equation, meaning you can put it here or here. So now to find T, just replace it here. So that will give me T minus m1 is what? By the way, don't use the formula. I can make the formula for T also. You don't use the formula. So let me take this away. So now it is a little clear. Let me move a little bit up. So now to find T, what you do? T minus m1 times gravity. So m1 is what? M1 is 15 times 9.8 equals to m1, which is 15 times 2.96. That's my acceleration, m1a, right? 2.96. So now what you do is, well, some of you may have seen the formula, which is m1 times gravity plus acceleration. That will give tension. So actually don't use that. Let's do this. So T, this gives what? T equals, so this goes on the right, will be plus. So basically what it becomes is 15 times 2.96 plus 15 times 9.8. Okay, so I'll cover this. So let me all clear. So it's 15 times 2.96 plus 15 times, by the way, when there is plus and then when you multiply it, you don't need parentheses. The reason is first is the scientific calculator will take multiply first, so it doesn't really matter. So times 9.8, and that gives you 191.4. So the tension will be 191.4. So 191.4 Newton. So now the reason I'm saying I don't recommend you to use direct formula and solve the problem is, so now let's make another problem, which is let's say another simple problem, which usually you have, I think we did in the class, one of the problem in where the example, yes, like the example 5.12. this is what I did in the class. Okay, so hold on. So if you look at this problem, the bottom one, let's see this one. So here example 5.12, here same thing, it's pretty much same this problem. The thing here is, rather than the left side this mass hanging, now it is on a flat surface, a frictionless surface, so it's a glider. All right, so let me make this question just like example 5.12, but I use these same masses. Okay, now see what happens. So this one is, I'm giving an example 5.12. okay, example 5.12. look at the difference now. Now you have the same mass, but in that example they use like M1 and M2, but now I'm going to use the same numbers, let's say. So you have, instead of this brick, now you have the same brick, and then this is attached. Now you have your pulley here, okay, and then, well, this is your table, right? And then you have this thing, same problem. All right, same problem. So let me take this one M1, same thing, which is 15 kilogram, and this one, let's say M2 equals 28 kilograms, same thing, exactly same thing. Now let's deal this thing. What happens here is, again, let me use my red pen. So my weight will be here, right? This will be M2 times gravity going down, and there will be tension up, which is T. Same thing here, it will be tension this way, T, right? The thing here is weight is going down here. So this weight has nothing to do with this tension, because this is in the vertical direction, the tension is in the horizontal direction, right? So now this will be balanced by something called normal force, right? So this and this will cancel, they are equal, cancel, and there is nothing to object or nothing to resist this tension. So in this left side, which is left side here it was T minus M1 times gravity is M1A. In this case you have same thing, T, but there is no minus, because gravity, in this case it was down, so gravity was opposing the tension, right? But here the gravity is not opposing the tension, so the tension is nothing but just tension is the reason why it goes M1 times acceleration. It's the only one thing there. On the second part is exactly same thing as we have here. All right, so basically this problem and this problem is exactly same. I'll change a little bit later on, but for now I'll do another problem which has, let's say if there is a friction, so that is kind of a gravity force here. Friction is the one that will oppose this tension. So if there is a, so this is frictionless, so this one is frictionless. So only in case of frictionless this is this. If there is a friction, then yes, in place of m1 times gravity, now you have frictional force. That's the one which is opposing to tension. All right, or Fk. So to solve this problem, T equals to m1 times A, and the other side same thing, mass 2 times gravity minus tension will give what? Will give mass 2 times acceleration, right? So when you solve this, T equals to m1A, just replace this. So solving 1 and 2, equation 1 and 2, or whatever you call it, m1 times gravity minus m1 times acceleration will give you m2 times acceleration, right? So what else is there? So just simplify this. So this one will be m2 times gravity equals this one will be m1 plus m2, because m1 goes on the right, becomes positive, m1 plus m2 times acceleration, and your acceleration is nothing but mass 2 times gravity divided by m1 plus m2. Again, if I ask you something like this, don't straight put this formula, because this is different than this, right? So depending on the situation of the masses, your formula will be different. So the bottom line is, you cannot just memorize the formula for such specific cases and just write down the formula, plug the numbers, get the answer. No, that's not what I want. So I want you to really understand the problem, and if you even memorize it, first you make sure you derive it, how the mechanism works, how the physics works, and then I need the physics part, not your just the math part, okay, or just the formula, memorizing formula and plugging the numbers. Okay, so this will give you m2 is what, 28 in this particular case, times 9.8 divided by m1 plus m2 will give what, which is 15 plus 28, and this will give me what, 28 times 9.8, 28 times 9.8 divided by, since it has 28 plus 15 in the parentheses, so you have to use like 15 plus 28, and then this will give me 6.38. okay, so now this will give me 6.38 meter per second square. Look at the difference in the previous. We have the same mass, exact same mass, right? One was just hanging, another one is gliding. So the difference is, of course it makes sense here, the acceleration here is more than in this case, because this was counteracting, so of course it makes sense it is slower, but this one is not counteracting because the weight is balanced by the normal force. So of course there is no extra force there on this particular case. So of course this, even though they are same mass, this moves with faster acceleration, okay, with more acceleration actually. So similarly you can get the tension also. Tension is nothing but m1 times A. So tension, just plug it there. M1 is, what is M1? M1 is 15. M1 is 15 times 6.38. So when you see here, it is, what is it, 15 times 6.38, so it's already there. I just want to multiply by 15, so I'm going to multiply by 15. So you see here it is 95.7. so this is 95.7. So you can see there in this particular case your tension is less than the previous case, because of course it makes sense. Of course it makes sense because this is more tense, because more force and counter force, and in this case it is less tense. Let me do another problem, which is now let me go here. Almost same problem but a little bit different, which is from, let's say I'll take it from the book. Let's say this one, which is 5.34. okay, 5.34. I don't know if you can see this. Let me see. Okay, there you go. 5.34. This is pretty much similar to the one that I just did. So what it says here is, consider the system shown in 5.34. Block A weighs 45 Newton. Now this one, not the mass, it's the weight. So I believe you know how to get mass if you want from the weight. All you have to do is just divide by, yes, that's correct, that's 9.8. I believe you are listening me. Okay, and block B is 25 Newton, which is, you have the mass also. So basically if it gives you in Newton, it means you know the mass. In other words, just divide by 9.8. that's the mass of A and mass of B is given. Once block B is set into downward motion, it descends at a constant speed. It descends at a constant speed. When it says descends at a constant speed, it means what? Constant speed means, what is it? What is the acceleration? 0. Very good. Yes, that's 0. So when it goes down with a constant speed, it means the acceleration is 0. So when the acceleration is 0, it means the net force here is what? Is what? 0, right? So calculate the, now it means what? Since the net force is 0, means the tension is balanced by the frictional force, and here also the tension is balanced by the, there is no m times a. So in other word, let me copy this one. So in this case your acceleration is 0, meaning t and then minus has to be the friction. So t minus, because t is going that way, so something is opposing this way, which is friction force. So t minus friction force is 0, because no acceleration, because it says constant speed. Okay, so now in that case what happens is, all you have to do, same thing, all you have to do, your acceleration is 0, t minus frictional force equals mass 1 times acceleration, and in this case again, sorry, 0, and in this case m2 gravity minus tension will also be 0. All right, this side there is nothing extra, only thing is this is 0. So now let me take this aside, and let me, how do I do it? Okay, let me put it here back. So I will draw the same thing once again, all right, which is question number 5 point excuse me, 5.34. okay, so let me see if I'm on the right side of the page. Okay, so here this question is 5.34. It looks like light is not working properly. I hope you can still read it. Anyway, I'll scan these papers and then send it by email, okay, and just in case. So let me draw. Okay, I'll make it two side as before, so that I can do another problem here. You know what happens if well, I'll tell you later. So now in this case you have same thing, you have a pulley here, you have a pulley here, and there is a mass here, right? This one is your mass here, and this one is okay. Sorry folks, the phone was off. This is Dr. Khanal once again. So we were doing, so let me recall, we did 5.15 problem, and then how about one mass is horizontal, and then what happens is you just don't use this opposing force M1 gravity, so that thing will be 0, this guy will be 0, everything else will be same. Now, and in this case it was frictionless. Now what we did was we tried another problem with a friction, and that was we were trying 5.34. so let me go 5.34. we were doing this problem and suddenly we got disconnected, so I don't know how it's getting a hard time to show you this problem. Oops, how do I show it? Okay, maybe this way. Okay, doesn't make sense. Hold on, I don't have space here. Hopefully, okay, there you go. All right, so in this particular problem, what it says is, consider the system in this figure. We have same two blocks as before. Now it says the weight is 45 Newton. Block A has a weight 45 Newton. Block B has weight 25 Newton. Instead of giving you mass, now it gives you the weight. So you know how to calculate mass from the weight. So weight known means your mass is known. All you have to do is divide by 9.8, right? Divide by acceleration due to gravity. Okay, so now once the block is set downward motion, it descends at a constant speed. So when it says constant speed, what it means is acceleration 0. So there is no acceleration. So there's a key. Remember, there is no acceleration. So in other words, if you recall the previous problem where the tension was equal to mass times acceleration, now this tension is equal to 0, in other words. So because mass times acceleration is 0. But how can the tension be equal to 0 is because it says calculate the coefficient of kinetic friction between block A, and because there is a frictional force here. So earlier problem we considered this is frictionless, but now if it is friction, then when this frictional force balances the tension, or if those two are equal, then there is no acceleration. So that's the key in this particular problem. Okay, so let me draw the figure once again. Let me draw the figure. This is the problem number. It's the problem number. Let me use a pencil. Oops. Okay, let me use this pen. I'm gonna use my red pen. I hope I'm with the proper thing. So this problem is 5.34. So let me draw the figure. It is, you have like mass A is connected, it's on the table, it's connected with a string which has, this is a table and which rotates in a pulley, and the same counter mass. There's a block B, this is A has 45 Newton. So I write here weight of A, this is 45 Newton, this guy is 45 Newton, and weight of B equals to 25 Newton. So that's given. All right, so now in other words, if you know the weight, it means it's like the mass, right? Okay, so now what happens here is, if you let it go, if there is a friction, now if I draw the forces. Actually this WA goes downward, which is usually equals to mass times A equals times gravity. That's how we learned earlier, right? Okay, so this will be equal to something called normal force. I call it NA because that's normal force of A. And this side, as usual, I call it tension, right? Tension is the one that produces acceleration, but in this particular problem there is no acceleration. So here is something called a friction. So that friction is, I call it Fk, which Fk is basically mu times Na, which you know this formula we did last time. So now if I want to solve this problem, same like before, let me recall exactly the same problem what we did earlier. In this case T, but there was nothing. That's why T, there was nothing, so it was M1A. But now in this problem there is no acceleration, no A, but there is some other opposing force. So in other words, this is basically T, right, tension, minus this force, frictional force, equals, used to be mass times acceleration, but now there is no acceleration, so basically it is zero because of this friction. So what it means is T is equal to F times K. This is on this side. So basically T equals to F times K, frictional force. So frictional force is nothing but mu K times Na, right? So I'll leave it like this. Let me go on the right side. Now what we have on the right side is again similar as what we have done before. The right side is exactly same as earlier. So right side was what? Weight of B, which is also called mass of B times gravity, right? And then this side is tension. So on this side, if you look at that side, what you have is WB, which is also, well, let me show you what we had earlier. So basically on the right side it was mass 2 times gravity, which is also called WB, all right, weight of B. I don't want to write it here. Weight of B minus T is m2 times A, but in this case my acceleration is 0, so WB minus T, so this guy will win, minus T, I don't know which one will, let's see, equals to, this is also 0. I don't want to write mass times A and again equal to 0, A equals to 0, that's why mass times acceleration equal to 0. So what it means is WB is given here 25 Newton. So what it means is T is nothing but 25 Newton. So it's known, right? Because T goes on the right, so this is equal. So now when T equals to 25 Newton, you just go back. What you find here is mu K and Na, right? Na is nothing but weight because these are equal. So when you plug this thing here, what you get is mu of K times Na. Na is nothing but weight because this and this will be equal. So Na is nothing but weight times A must be equal to 25 Newton. So if I get mu of K, this is 25 Newton divided by WA, dividing both sides by WA, so that is nothing but 45 Newton, and this will give me, what is the calculator? Again, let me use the calculator. So after using the calculator, I get 25 divided by 45, which gives me 0.555. Okay, so this gives you 0.555. So actually 555, another 5, so that is 556. So by the way, mu K as usual, it doesn't have unit because it is just the coefficient without unit. Now one part is done because what it says is calculate the coefficient of kinetic friction of the block A. So this is the first part answer, right? And what it also says is a cat also equal to 45 Newton falls asleep on top of block A. Now the question here is The next part is cat sleeps on top of. So let me draw another one. So the same thing, let me draw it here. Same thing, same thing. You have block here, you have A, and a cat sleeps there. All right, so cat of what it says, cat also weighs 45 Newton. Oh, okay, almost similar. So maybe I can make it even bigger. So cat is also 45 Newton. So this one is also 45 Newton, and the cat sleeps on top. So what happens now is, now of course this will slow down technically, right? Because if there is one more load, so it slows down. But for now, let's say we don't know what happens. All right, so let's figure out. All right, same thing. You have your weight B, right? You have your weight B, weight of B. This is weight of A. Now weight of C. There are two weights. All right. So now what happens here is the coefficient of friction remains same. Your formula will be exactly same thing, but now there is an acceleration. All right. Now there is an acceleration. Now the question is, what will be the acceleration, right? So let's say this is T again. All right. So T will be same as T, of course. So same thing here. Same thing here means I'm trying to using like a red pen and pencil. So let me go back here. So now T, same thing, T minus Fk, because the frictional force goes this side, right? T minus Fk will be mass times acceleration now, mass of A. All right, now we have like mass times acceleration. Remember earlier it was what, T minus Fk, this one was 0. But now when cat sit there, those two tension will not be equal. So in fact this frictional force will be more than tension. So basically this becomes more. So I know the answer will be negative. But let's see, right? So T minus Fk is Ma, just like what you have done here. On the second part, it's again same thing. Second part, same thing means what? Now Wb will, let's say, win Wb minus T, right? So Wb minus T will be Ma. So here Wb minus T will be mass of B times A, right? We need to find out A. So now here's the thing. Fk is known, Wb is known. Well, mass is also known because we know the weight, so mass is known, of course, right? So Ma, actually this is not A, AC. You have both A and C together now. It's not only A. Okay. So everything is known. What you need to find out is the acceleration. You can cancel T as before, right? As earlier, what you can do, you can cancel this T, and you have what? Wb minus Fk. Fk is what? Mu K, and then N. N is now AC both. All right, you cannot put only A, both A and C. Wb minus Fk equals, A comes factor out, so M of AC plus M of B times A. So now you cannot put direct this formula. Okay, so let me use this. So your A is technically, it is what? W of B minus mu K. NAC is what? W of A, because NAC means weight of both of the thing, right? Weight of AC. So I just write here weight of AC, and then divided by mass of AC. What you can do here is you can multiply by gravity so that it becomes weight, and then divide by gravity. You can do that, or what you can do is you can get mass from the weight. Weight is there, you divide by gravity and get the mass, and just plug mass there. So whichever way you feel comfortable. Okay, So now this one is, if you want to make it to weight, so you can just use weight of what is it, weight of AC plus weight of AC plus weight of B. It means I'm multiplying by gravity. Okay, let's say I'm multiplying by gravity, but you have to divide also by gravity, right? So multiplying by gravity will give me weight. All right, multiplying by gravity will give me weight, and that thing goes down. So but now I have to, what, on the this gravity which was on the left, it goes on top, so I need to multiply here by gravity. By the way, you can do it in your own way, okay, these things, or you can just plug it here, get your mass of A and C, add them together, or you can go this way. So now if you do this, weight of B is what? Weight of B is 25 Newton, right? Minus mu K is what? What is mu K? Mu K is 0.556. W of A and C, both of them, weight of both of them is what? 90, right? I don't need to write Newton because I'm not dealing with the units now. All right, because 45, and then this is also 45 Newton, this is also 45 Newton, so total is 90 Newton, right? Divided by, this one is again 90 Newton, plus this WB is 25 Newton, right? So WB is 25 Newton times 9.8, this is gravity. So all you do is simplify this, and let me use calculator as usual. So what you can do here is, what is the calculator? Okay, calculator. So let me start with here, 25 minus 0.556 times 90 times 90 times 90, I put it equals, so it is negative here. All right, times, I'll give 9.8, or I can divide this first, divided by 90 plus 25, which is 115, right? 115. Or if you get confused, just do it manual. Let's do like 90 plus 25, and then parenthesis close, so this will, and then now you multiply by 9.8. So this is what you get your acceleration, minus 2.13. all right, so the answer will be minus 2.13 meter per second square. So what it means is, of course it was going with a constant speed. Now when it goes with the constant speed, and if you put one mass on top of the sliding one, that will definitely slows down. So when it slows down means what? The acceleration is negative. So I can also add one question. After what time, or how long will it take to stop, take the mass W to stop? Or in other words, at what time the final velocity will be 0, or at what time the system comes to rest. Okay, so in that case what you need to do is, you have the initial, you have to have the initial velocity. It says only constant velocity, but if I ask you at what time it comes to rest, then there must be, if it is moving with the velocity of certain thing, then at what time it comes to rest means your initial velocity will be given, is like chapter 2, initial velocity will be given and final velocity will be given, and you have the acceleration, and if you have three things, you can get time, simply v2 minus v1 divided by a. You can do that one if I ask, by the way. Now let me go almost similar. Let me do one more problem, which is almost similar. Now what happens, instead of flat, now let's have like inclined plane. So let's do one problem which is something, okay, let me see, 5.74. So this is pretty much similar problem. Now the difference here is in this particular problem, in this side is the same thing, no problem. This side is what? M2 gravity minus T equals to MA. But here's the thing, this T is on this side. Is there any force here? There are two forces actually. The first one is the component of the gravity, of the weight. The weight acts this side, so it had some portion on this side, right, which we deal in the class. So this side will be the sine of alpha, and the normal component will be cosine of alpha. That's what we did. We did a little of trigonometry there in the class, so I hope you still remember. So if gravity is g this side, so this side would be g sine of alpha, okay, on this side. So mass times gravity sine alpha will give you force on this side. So that's side. So not only that, the other thing also is there, because it is also friction. So there is also friction, means friction also acts on this side. So in reality, in this problem, let me do that problem, so which is pretty much similar again. All you have to do is identify all the forces and just get the total force, which is equal to mass times acceleration. So this one is problem number 5.74. So I write down here 5.74. Right, so 5.74 problem is same thing, pretty much same thing. Now you have an inclined plane like this. Now the pulley is here, your block is like this. It's not only frictionless, but it also has friction, and since it's inclined, right, since it's inclined, it also has weight along this direction, so another force along this direction. So here is another mass, so A and B, or what it says, M1 and M2. Okay, book says this one is M1 and this one is M2. I think the mass M1 and M2 is also given there. So M1, it says, let me show you once again. So it says M1 is 20 kilogram, alpha, this angle is given 53.1, the coefficient of kinetic friction of the M1 and the inclined plane. So coefficient of this mu k is given. In the previous one it was not given, but now mu k is also given. What must be M2 of the hanging block if it descends 12 meter in, oh, here's the trick here. So M2 is not given, right? So M2 is not given, but if M2 is not given, then acceleration should be given. Acceleration is also not given, means what? There's a clue to get an acceleration. So of hanging block, if it descends 12 meter in the first 3 seconds. So that's important. What must be M2 if the block descends 12 meter, which is y, in first 3 seconds? Time is 3 seconds. So first 3 seconds means your initial velocity is 0. You start with 0 and then it keeps on moving. So in other words, y equals to v0t plus 1 half at square, where v0 is 0. So basically half at square. Just go back to chapter 2 again. So from here you get an acceleration, because you have time, you have 3 quantities there, time, initial velocity, and the displacement. So you can get, if you have 3 quantities known, you can get the remaining 2 quantities. I already discussed in the class. So now let me copy this one. I'll copy M120 and then alpha this and then mu k. Those are the things that's given. And of course, to get an acceleration, displacement and time is given. So I need those quantities. So here, let me draw the diagram, the force diagram here using this pen. The mass times gravity actually acts downward, right? We know this very well. So this side, the component of mass times gravity on this side will be simply mass gravity sine of alpha is given there, sine of alpha. We know this thing. We also know this side will be mg cosine of alpha. So basically that will be your n, right? So that means your friction is also this side. I just want to add here. so your friction is also this side. So not only the gravity pulling here, but also friction is opposing this tension. So tension is here. So here is the tension. Same here, it's not a problem because you have mass 2 times gravity. So it's pretty much simple. On the right side, same thing, m2 gravity minus t is ma. On the right side is same thing. On the left side, now you have tension, and then tension minus what? Tension minus, you have mg sine alpha, and then another thing which is the mu mg cosine of alpha, which is mu k. So in other words, similar to this. So let's see here. It's actually t on the left side. Look here, left side blue. Let me draw it here. I'll keep the space to put those quantities, whatever is given there. So okay, let me copy again once again. Why do I delete? Okay, so given m1 equals to 20 kilogram, alpha equals to 53.1 degree, and coefficient of kinetic friction is 0.4. Those are the 3 quantities given. Okay, and then there are a few more given to get an alpha, but I'll go there. I mean the acceleration, I'll go there later. But for now, let me try to relate these two problems, why they are similar. T minus f, same thing here. T minus Fk, of course Fk is there, friction is there, right? There is Fk. I don't wanna put a mess there, but let me draw it somewhere here. So this side will also be f of k, which is mu k mg cosine alpha. We did that in the class, right? So minus Fk. Not only this, there's only one t, but this side you have this and this, both of them, because weight also, in this case there was no weight, because weight has no component on this side, right? Because this side is like your 0, your angle is 0, so mg sine alpha, which is sine 0, makes 0 on this side, so this has nothing to do. But if it is inclined, then weight comes into action. So there's another thing here. This guy is same thing, but we need to take into account this guy also, sine of alpha, and this will give me what? Mass. This is mass 1, right? Mass 1. So mass 1 of acceleration, right? On other hand, other side, same as before, which is, where is it? Wb minus t. Wb means mass times gravity, which is W2 minus t. Same like here is the same thing. This minus this equals to m2 times acceleration. So there is nothing wrong here. Now the problem is we don't know m2 also, we don't know acceleration also, right? We can cancel t, okay, right? We can cancel t. If you solve it, if you simplify it as before, you can just cancel this one, and then what you can do is, this is plus, this is minus, you just simplify this, which is you write down mass 2 times gravity as is, and then this is gone, right? On the left side you have minus of Fk. In case of Fk, I can write here mu k m1 times gravity cosine times alpha, right? This is Fk. If it is not inclined, by the way, this will be mu k m1 times gravity, only this much, right? Which is the normal reaction. Okay, so minus we have left here this is also m1, right? m1 gravity sine of alpha, right? So far so good. Sine of alpha, left side is done. On the right side I have equals to, we need to add those two, so this plus this will give me m1 plus m2, and then I put here acceleration a there. Okay, so basically our answer is what? Our answer is to find m2, right? We just need to solve it, but we don't know a also and m2 also. We have the equation, we have all other things, we have m1, we have gravity, we have alpha, we have almost everything, but we don't have this m2 and this guy, right? So what I'm gonna do is I'm gonna bring this guy on the left. So my m2 will be on the left, or I can get acceleration and then substitute it and simplify it. You can do that way also. But to get an acceleration, there's a clue. To get an acceleration, there's a clue. I'll use my pencil because I have the flexibility to get the, change the ink. So what it says is, to y is given 12 meter in the first 3 seconds. So t is given 3 seconds. So first 3 seconds means your v0 starting velocity along y is 0. So you don't need this. So in other words, the formula will be what? Y equals to, let me use this little space here. So from here, what it means is y equals to v0, this thing, v0t, which is nothing, plus 1/2 a t square, right? So that's the acceleration of this one. So y is what? 12 equals 1/2 a is there, and then the time is, three square. So acceleration will be 24 divided by 3 times 3 is 9, and 24 divided by 9, let me use calculator. So 24 divided by 9, this will give me 2.6667, okay, meter per second square. So now I have an acceleration, this guy. All I have all the information here other than m2. So all I need to do is just plug everything here, solve for m2. Okay, so let me do it for you. So m2, which is I don't know, now I can use back my red ink. So m2 is the one that I don't know. Gravity 9.8 minus mu k, which is given 0.4, 0.4. m1 I have it 20. Gravity I have 9.8. Here's the thing, this is 9.8. okay, let me use, otherwise like dot times and decimal looks like similar. So and then what, cosine of alpha I have 53.1 degree, right? Minus, let me keep going, minus m1 is again, what is it, 20, right? m1 is 20 times 9.8 sine of 53.1 equals to m1 is 20, m1 is what, 20 times a is what, oh, a we know, a is 2.7, oops, 2.67, I'm running out of space, 2.67, and a is 2.67. so all you do is simply simplify this. So how we simplify this? I want to bring those two together. So I have here 9.8 m2, right? 9.8 m2 minus 2.67 m2 equals, let me simplify this. I want to take this on the right side, so whatever it comes will, when it goes right, it will be positive, and this also goes right, will be positive, and this is already on the right side. So let me do it step by step. Okay, so let me do this thing. Let me copy this one, 2.67 times 20. All right, I'll just leave it like this, 2.67 times 20 equals 53.4. so this one I write here 53.4. now this one plus, because I want to take it right, it becomes plus. So okay, so what happens here is, okay, excuse me, what happens here, let me see. So yeah, let me do with this. Okay, cosine of 53.1, cosine of 53.1, I want to make sure it is in degree. Yes, it is in degree, so I need cosine of 53.1 times 9.8 times 20 times 0.4, so this will give me 47.07. so 47.07, and this one also goes on the right, becomes plus, so I'll write here plus. Let me clean this up, and again sine of, let me start with there, sine of 53.1, I make it parenthesis close, and then times 9.8 times 20 will give me 156. Oops, what happened here? Something happened here. Oh, something happened here, the light went out or something. Okay, so this gives me 156.7. So for some reason I'm losing the light, but I'm almost done. So now what I'm gonna do is 9.8 minus 2.67. 9.8 minus 2.67 will give me 7.13. 7.13 of M2 will give me, you just add those three. So when I add those three, 53.4 plus, what is it, plus 47.07, and then plus 156.7. So equals to 157.17. so 157.17, or your M2 is just divide by 7.13, so that one divided by 7.13 gives me 36 point something, 36 kilogram. So basically this mass is 20 kilogram and this mass is 36 kilogram, so that will give the acceleration of 2.67 meter per second square. In other words, and that's it, the question, I think. Is there any more question there? It is from rest. The system is okay. So here's the thing, which is 5.74. since it starts from rest. Alright, that's all for now, folks. Okay. Alright, I'll see you in the class.